The first piece of this assignment is to calculate the mean and standard deviation of this set of measurements. So again, we've done this before. We'll go into descriptive statistics in Excel. Make sure that your measurements are all highlighted. The output range here, I'll just list something that's, again, on this sheet, and make sure summary statistics are clicked on, and there you have your mean, your standard deviation, all the statistics that you could want. The second piece to this is to go ahead and come up with a histogram for this data. So again, in Excel, I'll choose histogram, input range, make sure that your measurements are highlighted, output range, again, just making sure that it's on this sheet, and I'll click chart output, and there you have a histogram. If you want to close the gaps, we did this the first assignment, I believe. You can right click on the bars, and then you can slide the slider down to no gap and hit OK. The third piece of this says calculate the z-scores for these particular measurements. And again, we did this, the last assignment. So I'm not going to do each one of these, but remember the typical z-score when you're dealing with a sample just says take the measurement that you have, like 468.09, and subtract the mean value from it and divide that by the standard deviation. So in the case of this first measurement here, you come up with a z-score of negative 0.57. The third part of this says look for any values that are outside plus or minus 3 standard deviations. The only one that even comes close is the second one, as you take 468.01, subtract it from the mean value, and divide it by the standard deviation of the sample, and you can see that comes up to negative 2.46, not outside plus or minus 3 standard deviations, but still pretty far out there on the limb of the normal curve. So you can go ahead and do that, for the rest of them. Again, I don't think, we talked about using the dollar signs to hold a place constant. I mean, if you wanted to do this, put the dollar signs in front of the standard deviation, and then, you could actually just copy this equation on down, and there you'd have all your z-scores for everything. The last piece of this really deals with the chapter that we're in, and the last piece of this assignment, piece number 4, says consider that these measurements that you have here are from a sample of one day. So maybe we took measurements almost every hour or something like that. But let's say that these measurements that are taken every hour, hour and a half, are repeated daily, and this goes on for years and years and years. Then this one day would represent a sample of a larger population. But how does the mean value of this one day compare to the mean value of the whole population if you were given that mean value? Well, we can do this comparison based on another z-score. The only difference is we're comparing the mean of these values to the mean of the population, which is, might be days and days and days for years and years and years. In order to do this, it's still the same z-score population, z-score calculation with one twist because we're dealing with the population. So the z-score for the population would say, let's compare this mean value, and I will put parentheses around this just to be sure. Let's compare that mean value to the population mean, which we were given as 468.06. Now here's the trick when you're dealing with z-scores of comparing means from a sample to a population. You don't divide it by the standard deviation, you divide it by the standard error. And when you do that, you come out with 6.03. What you got to realize is that's a huge z-score. And what that's saying is this mean value of 468.1145 is just way, way out there on the limb. The probability that you'd get this value, or the probability that you'd get a higher value than this, is just minuscule. I mean, because this is really just an outlier. It's way out there on the edge. You can look at your z-tables. They don't even go up, I think, past 4. So that shows you how far out there on the limb that actually is.